This is the fifth lesson on the topic of algebraic expressions, functions and iteration with me, Mr. Riley. In today's lesson we'll be learning about factorising and simplifying algebraic fractions. Here are the stages to today's lesson. First of all, we'll factorise quadratic expressions. Then, simplify algebraic fractions. Do a trick or trash, and then look at working efficiently. Higher extension today, be able to multiply and divide algebraic fractions. Factorising a quadratic. So we will look at expanding this bracket to get an expression and then see how we can use that to help us work out how we go backwards to put it back into the bracket to factorise. Let's expand that. X times x, x squared. X times 5, 5x. Both are positive, so now I'll put in a symbol. 3 times x, 3x. Both are positive. 3 times 5, 15. Both are positive. Now that 5x and 3x go together to give me 8x. And the x squared stays as does that 15. Now the issue is, if I just came along and said, here's x squared plus 8x plus 15, we need to factorise that, place it into brackets. The issue we've got with that is that the 8x has lost information with regards to the 5 and the 3. And if I asked you to quite simply just factorise this expression, then it would be really obvious I've got some links. So the question is, how do I find that 5 and 3? Well, we know that 5 plus 3 is equal to 8, but I've also got 5 times 3 is equal to 15. So the method we use is get the factors of 15 because we're factorising. I do systematically to make sure I've got everything. So I've got 1 times 15, 2 doesn't go in, 3 times 5, 4 doesn't go in. Now we're thinking about 5, but we've already got that with 3 times 5. So I've done all the factors of 15. Now what can I put together to make 8? That's 3 and 5. So I've got 3 plus 5 equals 8. And 3 times 5 equals 15. And that's what I need to do with my pair of numbers. My pair of numbers both have to multiply to this 15 and have to add together or be put together to make the 8. Now it's just a simple case of putting that in the brackets. So we've got x, and then we had our plus 3. And then we have our x and our plus 5. And the question is done. This is factorised. We got back to where we started. Press pause and try the example questions. Then press play and I will answer the examples with you. Factorise the following quadratics. We start off with a 10. We've got 1 times 10, 2 times 5. Going systematically, 1, 2, 3 doesn't go in, 4 doesn't go in, we're back to 5, which we've already put down. Next thing we need to consider is what can I put together to make 7, and that looks like the 2 and the 5. And I just check that. I have 2 plus 5 is 7, 2 times 5 equals 10. So that satisfies what I want to do. Now all I've got to do is place that in our bracket. So I've got x plus 2 and x plus 5. And that question's done. Let's move on to question 2. So factors of 63. I've got 1 times 63. 2 doesn't go in. I've got 3 times 21. 4 won't go in, 5 won't go in, 6 won't go in, 7 times 9, 8 won't go in, and 9, now I'm back to 9, so I've got all my factor pairs. Now even though we had a negative, I still get the factor pairs out, just as we've done before. But now obviously we're dealing with negatives, I've got to think a little bit more deeply. I need to put them together to make a 2. 1 and 63, no, hang on, 7 and 9 I think I can use those to make minus 2. So how will I make minus 2? Well, I can do 7 take away 9, and 7 times minus 9 equals minus 63. It's important I do that check because we need to make that negative 63. Sometimes we can get a question wrong because you might pick a different pair where I can make that middle term, that where I've got a coefficient of x. However, when I multiply it together, it might give me the wrong sign or not be correct. So that's an important check. So let's put that in now. X plus 7 and x minus 9. Okay. Next one, 24. Lots of factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't go in, 6 we're back to where we started from. Again, I've got a negative, so which factor pair can I put together? Now, this is the importance of the check. I've got 2 and 12, which I can quite convincingly make 10, but I've also got 4 and 6. So this is where the check comes important. So how could I get to minus 10? Well, I could do 2 take away 12, which is minus 10, plus 2 times minus 12 is minus 24. But we had plus 24. So that pair is wrong. Now let's look at 4 and 6. So we've got minus 4 take away 6 is minus 10. Minus 4 times minus 6 equals, two negatives give me a plus, that's plus 24. So that pair, this pair was wrong, this pair is correct. And now I'll just substitute that in. So we got x minus 4 and x minus 6. Last one, bit more tricky. We got a negative coefficient of x squared. So what I need to do is essentially think about it in terms of making that all positive, that x squared positive, and I can do that by taking that out on a bracket. However, that's going to reverse the sign of everything else. If we look at that, if we put that negative in, a negative and a positive x squared gives me negative x squared, a negative and a negative 12 gives me positive 12, and a negative and a positive 35 gives me negative 35. So those two expressions are the same. Now I'll carry on like before. 1 times 35, 5 times 7, and which pair can I use together? Well, it's not really the 1 and the 35, so I reckon it's got to be the 5 and the 7. Let's check. Minus 5 take away 7 is minus 12. Minus 5 times minus 7, a negative and a negative give me a positive, so that's plus 35. Okay, so that checks out. So now I can put that into my bracket. I've got x minus 5 and x minus 7. That doesn't quite feel complete because these two are not equal, because here I had this negative sign. So now I need to place this back. Unsurprisingly, that answer is not finished off. I need to put that negative inside a bracket. And what we will see is for one of those brackets, it will reverse the signs. So I can put down, I'll just write underneath here so we can see it, minus x plus 5, and then my other one stays the same. And that's that question finished. Press pause and then complete the independent work. Then press play and I will reveal the answers. We've got our expressions we're multiplying out here, and we're going to use this to help us see one that kind of gets students tripped up. So we've got x times x is x squared, x times 4 is 4x, positive and negative gives me a negative, 4 times x is 4x, positive and a positive, and finally 4 times 4 is 16. Positive and a negative is a negative. Now what we can see is that these two cancel each other out, so it just leaves me with x squared minus 16. Now the question is, how do I factorize that? How do I go back? Well, if I've got two terms, I just rely on my box method. That's not going to work. I haven't got anything that's common to both sides. And the reason being is because those four x's have cancelled each other out. They've disappeared. Now the clue is that this 16 is a square number. So if I just think of the square root of 16, I know I've got two answers. I've got plus 4, because 4 times 4 is 16, and minus 4, because two negatives gives me a plus. 4 times 4 is 16, two negatives give me a plus. So if I see this, I quite simply factorize it as x plus 4 and x minus 4, and that's done. So how do I, this is the general difference of two squares, and how do I factorize that? Well, whatever this might be, so let's say I've got x squared minus 49. What's the square root of 49? 7. So I've got x plus 7, x minus 7. Let's pick a different expression. Let's say I've got x squared minus 121. What's the square root of 121? 11. So I've got x plus 11 and x minus 11. This is a square number here. I'm not sure what it is, but if I take the square root of y squared, it's just y, isn't it? Think about that. Y times y is y squared. So the square root of y squared is y. So if I wanted to factorize this expression here, that would be x plus y and x minus y. Press pause and try the example questions. Then press play and I will answer the examples with you. So we've got x squared minus 100. We need to factorize the following quadratics. So I'm just going to look at the square root of 100, which is plus or minus 10. And I'll quite simply put that in now. So I've got x plus 10 and x minus 10. That's done. Next question, I've got the 49. Square root of 49 is plus or minus 7. So that gives me x plus 7 and x minus 7. Again, that's complete. If I look underneath, I need two things to consider. I've got the 36. The square root of 36 is 6. I'm only going to consider the positive answer. If we note, I could have actually looked at, for the previous two questions, 1. What's the square root of 1? 1. But we don't really put 1x in, do we? We just leave that. But the next one, the 16, I do need to consider. So 16, the square root is plus or minus 4. And now I'll put those in. So I've got 6x plus 4, and let's make that a bit neater, and 6x minus 4, and that's done. Press pause and then complete the independent work. Then press play and I will reveal the answers. So this is a type of question to look out for, and I'll show you why. So if I look, and if I box that up, I can actually see that I've got something common to both sides, which is 4. 4 times x squared, 4 times 9, that's a negative. So that would give me this. However, if I just showed you on the previous slide x squared minus 9, I asked you to factorize it, what you would have done is taken 9, found the square root, and know it's plus or minus 3. So with this type of question, we don't just factorize once, we have to factorize a second time, and you have to look out for this scenario of difference two squares where the number is seen again. So how do I factorize that? Well, I would just quite simply go, this is x plus 3 and x minus 3. Okay, well, these two are the same, so that just tells me I've got 4 bracket x plus 3 x minus 3, and we're done. Press pause and try the example questions, then press play and I will answer the examples with you. So this is one of those where I need to factorize it twice. That only becomes obvious a bit later on. Box that up. What's common to both sides is 2, so I've got 2 times x squared is 2x squared, and 2 times 100 is 200. So I've got 2 bracket x squared minus 100. And we can see that can be factorized again. So square root of 100 is plus or minus 10. So I will end up with 2 bracket x plus 10 and x minus 10. And now we are fully factorized. Press pause and then complete the independent work. Then press play and I will reveal the answers. Simplify the following algebraic expressions. So if we consider the first one, what I can see I've got common factors on the numerator and the denominator. So I've got a 3 that goes into both 3 and 12. So 3 divided by 3 is 1. 12 divided by 3 is 4. And I can also see I can cancel, that's x to the power of 1 if they don't make a notation. And if I consider x squared divided by x, that'll give me x to the power of 1, or just x. So that will cancel out, leaving me with 1 x over 4. or I could just simply write x over 4. The one on the right requires a lot more work. Now it's really mega tempting because I've got an x and an x and an x and another x to divide through by x. Unfortunately, that 5 prevents us from doing it. I can only divide through if I've got a common factor for all these independent terms. So this is not possible, and do not fall into that trap. Now, it will only say in the question, simplify. But you will actually have to factorize. And I consider each of those separately. So if I consider the numerator, if I ask you to factorize 2x squared plus 10x, you would have done that a couple of slides ago, no problem whatsoever. So we box that up, split that up. What goes into both sides? 2 and x. We need to factorize fully for this to work. 2x times x is 2x squared. 2x times 5 is 10x. So that gives us 2x, x plus 5. And that will be our numerator. Now we will need to factorize our denominator. And how will we do that? Well, if I, again, a slide ago said, please factorize this expression, you wouldn't have had a problem. You would have said that's 1 times 5, and that's it for 5, because 5 is a prime number. And obviously I can put 1 and 5 together to give me 6. So that would quite simply be x plus 1 and x plus 5. So I can place that in here. We have x plus 1 and x plus 5. Now these are touching, they're multiplying each other, so now I can divide through. So I can divide, I can see I've got an x plus 5 on my numerator and my denominator, so they cancel out, and that allows me now to write down the final answer. And that's done. This is the final simplified algebraic fraction. Press pause and try the example questions. Then press play and I will answer the examples with you. Simplify the following algebraic fractions. So I'm going to start out looking at the 14 and the 21. I can note 7. So that's 2 and 3. Next, a. I can't cancel the a with anything. Last one, b. That's b to the power of 1. And I consider b to the power of 1 divided by b to the power of 2. Let's take away, I'll get b to the power of minus 1, which is the same as 1 over b. Remember, b to the power of minus 1 is the same as saying what is the reciprocal of b. The reciprocal of b is 1 over b. Now we can put that in. So we've got 2a. I haven't got any b remaining on the top because that's been cancelled. Divided by, let's make that a little bit neater. Divided by 3b. That's factorized. That's simplified. We can't do anything else. If I look underneath, I'll need to factorize both those expressions. So starting out with 8, what are the factors of 8? I've got 1 and 8, 2 and 4. Which of those pairs can I put together to make 6? And what I can see is I've got 2 and 4. That makes 6. So I've got x plus 2 and x plus 4, all divided by, and now I'll need to factorize that bottom expression. I've got 3x plus 12, box that up, 3 goes into both sides, I've got x plus 4. So that's 3 bracket x plus 4. 3 bracket x plus 4 is my denominator, and what we can see, these two are equal, these two cancel out because they're the same, and that leaves me with my final answer of x plus 2 divided by 3. Press pause and then complete the independent work. Then press play and I will reveal the answers. Press pause and try the example questions. Then press play and I will answer the examples with you. Simplify the following algebraic fractions. So looking at those, we will need to factorize. So if we consider the numerator, I've got 6x squared minus 24x, and I'll box that up. What's common to both sides? I've got 3. Can I do better than that? I've got 6. And I've also got x. 6x times x is 6x squared. 6x times 4 is 24x, and I've got a negative. So that's going to give me 6x bracket x minus 4. Now let's go and look at the denominator. So 12, 1 and 12, 2 and 6, 3 and 4. Now it's not so obvious what I'm going to put together here to make x, but if I think about that as 1x, that'll be a bit easier. So what can I put together to make 1, 3 and 4? I better use my check for that. So we've got 3 minus 4 equals minus 1. 3 times minus 4 equals minus 12. So that works. So that's going to give us, for the denominator, x plus 3 and x minus 4. What we can see is that x minus 4 can cancel, leaving me simply with 6x all divided by x plus 3. Let's look at our next one. Now, do I box that up? Well, my clue is that 49 is a square number, and if I consider the square root of 49, that will be plus or minus 7. Square root of 49 is plus minus 7. So my numerator will be x plus 7 and x minus 7, all divided by, let's make that a bit neater, eh? He says, third time lucky, what do we think? There we go. So now I need to factorize the expression for the denominator. So I've got 1 times, let's use, 1 times 21. 2 no, 3 yep, 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, then it gets me back to 7. I've got 3 and 7. However, I need to check. So minus 3 take away 7 would be minus 10. Minus 3 times minus 7 would be plus 21. So yes, that does indeed work. So we're going to get our x minus 3, our x minus 7, and again these can be cancelled out, leaving me with our x plus 7 divided by x minus 3. And that's done. Press pause and then complete the independent work. Then press play and I will reveal the answers. Tick or trash. Read the task below. Press pause and identify which of the 3 solutions is correct. Press play and I'll let you know if you are right. This is the plenary for today's lesson. Press pause and have a go at the task. Then press play and I'll do the task with you. So can we simplify the algebraic fraction? Well, I need to see if I can factorise first. So looking at the numerator, square root of 25 is plus minus 5. So I can factorise that. So we're going to have x plus 5 and x minus 5 for our numerator. And next job we need to work out the denominator. 1 times 15, 3 times 5 is going to be 1 and 15. So we've got x plus 1, x plus 15. Now, can I cancel anything out? No. So even though I've been able to factorise both the numerator and denominator, I can actually only simplify if I have a common factor for the numerator and the denominator that isn't 1, and that's not the case here. So my answer is no. It's not possible, and here's my model answer. Well done for completing today's main lesson. You are now ready to try the problem solving video and the higher extension video that go alongside this lesson.